In this video, I'm going to show two different ways of computing a vector cross product. And then to show that they're both the same way, I'm going to do it with the same two vectors, do the cross product 2 times, and if we get the same answer, it shows that they're both valid ways to do it, and whichever way is easier for you, that's the way you should do it. So the first one, we're going to create the 3x3 matrix. So the first column is always I hat, j hat, k hat. And then the second column is the first vector in the cross product, so the vector A in this case. So the components of A, 3 I hat, 5 j hat, and 2 k hat. And then the third row is the vector components of B, so 6 I hat, 1 j hat, 4 k hat. So then in this method, we are going to copy over these first two columns here that I'm circling to the right side of the 3x3 matrix that we created. So we're going to copy over the I column. So I hat 3, 6, j hat 5, 1. All right. So the first step is all of these diagonals going down to the right that I'm right now covering in an orange line, those are going to be positive, and they're all going to be multiplied together and added. So let's do that first. So we're going to have I hat times 5 times 4 plus j hat times 2 times 6 plus k hat times 3 times 1. Then in green here, I'm going to do the down and to the left diagonals, and those are all going to be negative. So it's going to be, so those are going to be minus, let's go from left to right. So minus 6 times 5 k hat minus 2 times 1 I hat, and then minus 3 times 4 j hat. All right, so let's combine these. So we're going to have 5 times 4 minus 2 times 1 I hat plus 2 times 6 minus 3 times 4 j hat plus 3 times 1 minus 6 times 5 k hat. All right. So combining these, it's 20 minus 2 I hat is 18 I hat, and then 12 minus 12 j hat, so that goes to 0 plus 0 j hat, and then we have a 3 minus 30, so minus 27 k hat. So I simplified this a little bit, 18 I hat minus 27 k hat. All right, so now I'm going to show you the second way of doing this, and hopefully we should get the same answer and prove that both ways work. So the second way here is going to be by doing the cross product as the sum of 3 different 2x2 determinants. So let me show you what I mean. So we're going to set up the cross product the same way with the I hat, j hat, and k hat as the first row, and then the components of A, 3 I hat, 5 j hat, 2 k hat, the components of B, 6 I hat, 1 j hat, 4 k hat. So what I mean by the sum of 3 2x2 determinants is we're going to take this I hat and we're basically going to cross out these 2 rows and take this determinant. So it's going to be the first part of this first part of this is going to be I hat times the determinant of 5, 2, 1, 4. So in the next one, we're going to subtract j hat times the determinant of these here. So it's going to be j hat times the determinant of the 2 by 2 matrix 3, 2, 6, 4. And then doing the same thing for k hat, we're going to do k hat times the determinant of 3, 5, 6, 1. So the reason we subtract this j hat here is just because it's in the middle, so it's a little bit, the properties of the 2 by 2 determinant are a little bit different. So just don't forget this negative sign here, it's very important. Okay, so then the determinant of a 2 by 2 matrix is you multiply the two diagonal columns. The diagonal column going down and to the right is positive, and the diagonal column coming down to the left is negative. So it's going to be 5 times 4 minus 2 times 1 I hat minus 3 times 4 minus 2 times 6 j hat plus 3 times 1 minus 5 times 6 k hat. Then doing this, so 20 minus 2, again, is 18 I hat. The j hat term, 12 minus 12, again, goes to 0, so that's minus 0 j hat. And then the k hat term is 3 minus 30, so negative 27 k hat. And again, we're left with 18 I hat minus 27 k hat, which is the same answer that we got doing it the previous method. So again, either one of these methods is completely valid. They both get you the same answer. I hope that helped. If you need me to go through any other examples or are confused on any other topics, please leave them below in the comments. Thank you.